just let me know. Yeah, my name is Callie. I teach on the Allagash River team at Massapequa Middle School. We're a 7th grade team. I'm the science teacher. Mary teaches social studies. Jen teaches math, and our new language arts teacher is here with us today. Last year, our language arts teacher from last year left, so she's not here. But our interdisciplinary unit was called the Power of One, and we used PowerHouse as the platform for it. An overall question we asked our students was, do I have the rights and responsibilities to planet Earth? And so again, they used PowerHouse to look into this question more deeply. So they embarked on a 3-month interdisciplinary unit contemplating their rights and responsibilities towards the health of our planet. The focus of this work was climate change, the impacts of climate change, and the platform that we used to kick this off was PowerHouse. So how we did that was, well, Molly came in and we used PowerHouse with the whole team in the beginning. And we started the year off with a really fun game that's actually on the PowerHouse website, the appliance sort game. We had students at that point bring home the paperwork and get signed up at home and try to link their CNC account to PowerHouse, which is a barrier if you teach in a rural district. Just as an FYI, some homes don't have smart meters. So there is a way to track energy use without a smart meter, but it's more time consuming. So as you can see on the left, we started tracking our students who created PowerHouse accounts, talked to their family about PowerHouse, tried to connect data to the PowerHouse, and ultimately connected it. And this actually was a lot more successful than this graph shows. Kids were very excited to put their dots on our chart. So, so that's where we began. A lot of independent research, and the questions we asked per content area were, how do my actions impact climate change in the ecosystem? So that was our science question. Language arts, how do I support my claims of relevant evidence? What are the different methods in which data can be displayed? So Jen did a lot of work with graphing, and PowerHouse is awesome for that. And do people have a right to clean air, safe water, and healthy environment? And that was our social studies topic. So at the end of this, we had a big, like a fair, I guess, and we opened our whole team up to any sort of visitor who wanted to come in and look at their research. And we had various requirements, and if you guys want to jump in at any time, I'm not explaining it thoroughly enough. You know, they had certain math requirements, they had certain social studies requirements, science and language arts, to meet the standard for this research project. And these are just a couple examples of student work. So after we did that, I kind of extended it in my classroom for a little bit longer with a select group of students, and we had some students do home challenges, and these home challenges are on the PowerHouse website. I had one student in particular who really got into this home challenge, and her parents aren't together, so she actually did this in 2 different households. So her goal was to obviously reduce her carbon footprint. She had been tracking her energy use in both homes for some time, and found some ways in both homes that she thought would reduce her carbon footprint. So in house number 1, she stopped using the coffee maker, and she used the wood stove instead to heat the coffee, and also stopped using the clothes dryer. And you can kind of see the timeline. As far as I know, she's still doing this. And then the data displayed, for those of you who aren't familiar or haven't logged into PowerHouse yet, you can see your energy use in various ways, whether it's a given week, and these are the month views, so you can see her energy use in that household for February, March, and April. So just by doing this one step, she, here's her data, she decreased her CO2 usage by 55%. 0.99%, and we'll look at what that actually means in a minute. But you can see the cost savings all the way on the right, and Molly helped her calculate this data. So it's pretty significant. And then the second house, she chose to shut off the lights and they're not in the room. She realized that this was a problem for her family. They just kept lights on. So they decided to make a pact and shut lights off when they left the room. And she had a significant decrease in this household too, and you can see the cost savings all the way to the right. So, yeah.
Do you know if she thought about, since they started to think about that carbon footprint, did she extend it to, well, did they in my family, have they made other changes as well?
I'm not sure. I just know this was the change that they made to track, you know, as far as the
But
measure.
she didn't discuss that or state that. I'm curious as to how it impacts overall.
Well, I think, you know, she realizes in the big scheme of life, like what her carbon footprint is, what we can, you know, like we definitely went over this in science class, you know, what contributes to our carbon footprint, how we can reduce our carbon footprint. But as far as this household, this is the one act they decided just to start the process and get into the habit of shutting off the lights and then leading to greater things, I think. This happened towards the end of the year, so I'd be curious to touch base with her. Yeah, when school starts. So you're kind of like, all right, given these values, like what does this actually mean? So I found this website, and you can plug in the value of CO2. Oops. So like, if I plugged in her savings of CO2, it tells you down here what this actually means. So this is her savings, and you look at it in different ways. I like the light bulb one. So it's kind of a neat way to give kids a concrete value of what they're actually, how they're actually.
What website was it?
Use this data.com. I just started like Googling calculating. You know, I don't know how like reliable it is, but as far as 7th grade, I think it gives them a good idea of what they're actually doing to help out. And there are other ones on the internet too. But you can plug in any of that. Like I could plug in that 55.99. Of course, it doesn't change the values very much, but it does change them. So, you know, slightly, but you get an idea. So that's a fun thing to do with them too. And then we also did the design challenge, which was a lot of fun. And our students used a mystery home data, or actually their own house data, to identify a barrier for that household. So they created a problem statement outlining the barriers and benefits of a solution. So they used like I said, their own personal electricity use data or the mystery house's data. So they might say, okay, we saw consistently at 6 a.m. the energy use would spike, or Sundays were, you know, a big day for energy. I mean, a lot of people do laundry on Sundays, so they might hypothesize, okay, Sundays seem to be the biggest offender. What's possibly going on in this house, and what can we do to help this household reduce its energy use? And this was a lot of fun. Oops. Well, I have some pictures of it later, I guess. So in addition to this investigation, they investigated various energy sources, coal, oil, natural gas, you know, our big offenders, and investigated various light bulb types. So we did some measuring of our incandescent CFLs, LEDs, and looked at what they were used for energy over you know, certain periods of time. And this morphed into renewable resources. And so this group of students got to work with renewable energy and start engineering their own renewable resources to help this mystery house or their own home in a hypothetical way. So if they started looking at hydropower, wind power, solar power. They came up with some really cool prototypes. And these are the kids doing some of their work. So, you know, they might say, you know, hypothetically start trying to, you know, if they saw Sunday was a big offender for home, trying to use solar panels to help the house reduce its energy overall, and then especially the impact on Sundays. But yeah, they had a lot of fun. And so our next steps, actually this is one group in particular. They got really into the hydropower function, and they chose hydropower as a renewable resource to reduce coal and natural gas. They saw that natural gas and coal were used a lot in this particular house. So they started looking at hydropower, but then they started asking themselves questions like, okay, so what happens in the winter in Maine? Is that a reliable renewable resource for this house? They're like, how do I build this water wheel, and at what point is the water wheel most efficient? How fast does the water need to go? Because they were doing these experiments in my classroom, and they automatically thought, well, the faster I turn on the water, the faster the water wheel is going to go, and that's going to be the best solution. Well, then they found out the water splashes everywhere, and they lose a lot of water. So they really started to problem solve and think, okay, well, we can work with angles of the little cells within the water wheel to make it the most efficient product possible, which was really, really neat because they came up with these questions on their own. So they did a good job. I was proud of them. And then so our next step is to increase the number of students linked to PowerHouse this year, increase the number of in-home challenges, and the kids doing their engineering work. So there's a lot of things you can do with this. I think the interdisciplinary was a lot of fun for all of us because it definitely goes into all facets of the curriculum. That's it. That's all I got. Any questions?
Yeah, we've got time for questions.
Yeah.
Just, I know when my team teachers tried last year, they had very few students who actually got their CMP data and hooked up to our house. They ended up using their homes.
The mystery home or the teacher home.
Yeah. So
Yeah.
how do you get your kids? I mean, I'm thinking like open house, really talk to parents, ask them.
So that's what we're going to be doing.
You are? Okay.
Yeah. So our open house is actually today. So we'll be talking about it then and giving them all that information that night. So we're hoping that will
Increase your numbers.
Yeah.
Do you know what percentage you had last year?
No, I don't. We actually, as the year went on, more kids and parents got really excited about it. But I don't know what the ultimate numbers were.
You guys had, I think, around 31% connection.
Was it?
Right? Yeah,
Okay,
which
just
is
like 20.
pretty good. But we're gonna, in a little bit, we're gonna show you, Caroline will show you kind of some ideas of activities you could do at an open house that we've done before, that we've done in Massabesic. That appliance sort activity will be downstairs, so you can kind of get an idea. And we've got the paperwork set out too, so you can see what kind of paperwork you would give to parents. And that home inventory too is a really great way for students that aren't connected to get some real data to work with. So and we'll talk more about that later too.
Anything my group wants to say?
No, it was great. It was fun, and the kids were very engaged. They all enjoyed it. The kids learned a lot. Nice job, Cal.
Oh,